International Life Sciences Institute, ILSI, is a nonprofit worldwide organization whose mission is to provide science that improves human health and well-being and safeguards the environment. By working with experts from the government, academia, and industry, our international entities address issues related to food and water safety, nutrition and health, risk science and toxicology, and sustainable agriculture and nutrition security. ILSI is a nonprofit charitable organization that works for the health of the public. ILSI has a commitment to achieve and maintain the highest standards of scientific integrity. It's who we are, and it is inherent to our mission. Our principles for scientific integrity mean we are pursuing objectivity, clarity, and reproducibility in order to ensure the utility of our scientific and scholarly activities and assessments. ILSI entities are membership-based organizations that receive funding primarily through membership fees. ILSI leads and publishes research to answer real-world problems. We offer a truly unique approach to conducting scientific research that allows our organization to facilitate conversations among global experts in a neutral setting. This approach achieves balanced and high-quality specific evidence that can be used for public benefit. All ILSI entities follow a strict code of ethics and believe that good science can have a positive impact on public health around the world. We all share these important guiding principles, and the projects within ILSI entities bring diverse science to the table, driven by unique priorities. You can explore those scientific research priorities by visiting www.ilsi.org. ILSI, building global partnerships for a healthier world.
Good morning, afternoon, and evening for some. Our guests at this kickoff session for the Food Systems Summit Science Days pre-events. We'd like to thank the organizers for the opportunity to present. I'm Jeffrey Smith, the president of ILSI Southeast Asia region based in Singapore. You've just heard a brief overview of ILSI in the intro video, so I won't elaborate further except to say ILSI is a global, nonprofit, member-supported scientific organization that addresses scientific issues of public health significance, chiefly related to food safety, nutrition, and sustainability. As mentioned, ILSI is largely member-supported, but all of our boards have a minimum of 50% of their members from the public sector to ensure public health focus. Our regional branch covers Southeast Asia, Australia, New Zealand, and I should point out this region is highly diverse, comprises nearly 10% of the Earth's population, with climates from tropical to temperate. We're pleased to present some scientific developments in the region, followed by a panel discussion. Now it's my great pleasure to introduce Dr. Maria Antonia Guillermo Tuazon, Dr. Tuazon, who will act as chair today. She is presently Nutrition and Food Systems Officer, the Food Nutrition Division of FAO in Rome. Dr. Tuazon has extensive experience with international agencies, having previously worked for the World Food Program, UNICEF, the World Health Organization, the Asian Development Bank, and the World Bank. She's worked in many developing countries in Southeast Asia, the Pacific, Africa, India, Bangladesh, and others, focusing on nutrition policy, scaling up nutrition, nutrition monitoring, maternal and child nutrition, and numerous other important topics. Dr. Tuazon was professor of nutrition and dean of the college as director of the Institute of Human Nutrition at the University of Los Baños in the Philippines. She holds a PhD in nutrition from Wageningen University, the Netherlands. We're very pleased she can join us today from the Philippines, where she's on home leave. With that, I turn the session over to Dr. Tuazon.
Thank you very much, Jeff, for that kind introduction. I think one thing you failed to mention is that part of my previous life, I also worked with ILSI, and you were my boss. So I join Jeff in welcoming everybody to this webinar entitled Science and Sustainable Food Systems in Southeast Asia, Challenges and Ways Forward. And as you can see from the flyer, this webinar is jointly organized by ILSI Southeast Asian region together with its partners. Just to give everybody a heads up, this meeting is being recorded, so then we will be sharing the recording later on, which would allow you to also share the highlights of this meeting. And we hope to be able to have some time to entertain some of the questions that will be appearing in the chat box. But just in case we don't get to answer all of them, please be assured that we will try to do an email reply to these questions or comments. Before I hand over the floor to our speakers, allow me to share a few points about the Food Systems Summit. So the focus of the Food Systems Summit in terms of objectives are fivefold. The first one is to ensure access to safe and nutritious food for all. And this, of course, is intended to contribute to achieving zero hunger and to improve access to affordable and nutritious foods, at the same time addressing improving food safety or increasing food safety. The second objective for the Food Systems Summit is shifting to sustainable consumption patterns. We know, of course, that there have been so many issues relating to sustainability, and this is one of the key objectives of the Food Systems Summit. We also are, another aim for the Food Systems Summit is to boost nature positive production at sufficient scale. This implies protecting natural ecosystems, managing sustainably existing food production systems, and restoring and rehabilitation of degraded ecosystems, including soil function. The fourth objective is to advance equitable livelihoods and value distribution. So, and the last objective is about building resilience to vulnerability, shocks, and stress. I think you will all agree with me later on that insofar as this webinar is concerned, the presentations as well as the panel discussions will definitely add value to achieving these 5 food systems objectives. Just in case you are interested to know who from FAO are the lead persons, then the names are reflected here, and you may want to also, get in touch with them. So this meeting is actually a contribution to the scientific group discussion. And for the scientific group, the specific objectives are the following. We want to be able to mobilize science for the Food Systems Summit. So this would ensure the robustness and independence of the science underpinning the dialogue of the food system policy and investment. So we also hope that the outcomes of today's webinar can be part of the science-based synthesis and analysis of the food system narrative in terms of aspirations and commitments. And lastly, as we listen to our speakers and panelists, we hope to receive some guidance on how we can effectively ensure that science contributes to accelerated and convergent actions from policies to programs to advocacy, communication, and engagement of all actors, especially the scientific communities like academia, research centers, innovation hubs, and the like. We are very fortunate to have with us, to have been able to gather an excellent lineup of speakers and scientists who will speak on the key challenges we face here in Southeast Asia, including how COVID-19 might have affected our region and how with it as we respond to the global call for food system transformation. It is evident that we cannot have business as usual if we want to ensure that our food systems deliver on sustainable food security and healthy diets. Moreover, we are just 9 years away from the reckoning day in terms of meeting the 2030 Sustainable Development Goals. So it's important that we also hear from our speakers potential entry points for effective nutrition actions to bring all countries back on track, and within the context of this webinar, specifically on how we can leverage science to fast track and scale up effective nutrition actions. I will go a little bit off script by introducing all our speakers at once according to the order of their presentations. Our first speaker is Professor Paul Teng from the National Institute of Education International in Singapore. He is the Dean and Managing Director of the said institution and is an adjunct senior fellow for Center for Non-Traditional Security Studies. And of course, as I have indicated earlier, he is an internationally recognized expert in the field of food security, commercialization, and biosafety of crop biotechnology, among many other areas of expertise. Next slide, please. The next speaker is Professor Brajesh Singh from Western Sydney University in Australia. He is a soil ecologist at Hawkesbury Institute for the Environment. And he has done a number of studies that identify the quantitative relationships between microbial diversity and ecosystem functions. And I think this is a topic that is also equally interesting. And so we look forward to his presentation. Next slide, please. Our last but not the least speaker, who will talk about achieving healthier diets and encouraging nutritious, affordable foods, particularly zeroing in on the roles of small, medium enterprises in the food system transformation, is Mr. Adi Lukman from the Indonesian Food and Beverage Association in Indonesia. He is now the chair of the said organization, and this organization champions the interests of the food and beverage industry in Indonesia and ensure the provisions of healthy food products. He is also the chair of the Permanent Committee for Development of Food Industry, Indonesian Chamber of Commerce and Industry, and is a member of several committees and alliances. So over to you, Professor Teng, for the presentation.
Thank you very much, Dr. Tuazon. Well, thank you very much, Dr. Tuazon, again for the virtual introduction. Let me start my presentation with the premise. And the premise is that when we talk about food systems, their sustainability and resilience, we really need to treat agriculture and food as part of a continuum. And this continuum runs from food supply chains to food environments to the consumer. The conceptual framework that was presented by the high-level panel of experts really summarizes this very well in this slide here. And we can see all the interactions that occur. So my first premise is this, that we need to treat food systems as a continuum, from production to processing all the way to consumer. Okay? Now then, the next kind of benchmark in our thinking is sustainability and resilience. I know that there's no internationally accepted definition for sustainability, but I think basically most of us agree that a sustainable system is one that can indefinitely meet the requirements of society, whether it's for food or fiber, but at socially acceptable economical and environmental costs. And of course, as we all know, sustainability assessment has grown as a science, where the rubrics for assessment are illustrated by some of these here, whether something is environmentally friendly, economically viable, socially just, and more recently, governance has become quite an important part of sustainability assessment. Now, resilience, what is a resilient food system? And I like the Johns Hopkins definition in particular. Resilience implies the ability to withstand and recover from disruptions in a way that ensures a sufficient supply of acceptable and accessible food for all. So having established these benchmarks in our thinking, we've all been influenced by COVID-19. So one of my temporal benchmarks, in fact, is what was Southeast Asia before COVID-19? Now, we all know that Southeast Asia has 11 countries with varying levels of income, and their systems here, our systems here, in fact, are underpinned by over 100 million smallholder farmers, many of whom are subsistence. They're the ones who really anchor the food system. Now, we also know that agriculture in Southeast Asia has been declining in its contribution to the national GDP, but it is still an important source of employment. And also, Southeast Asia agriculture is responsible for many food items and is among the top 2 to 3 producers in the world. Rice is a classical example, Vietnam and Thailand consistently being in the top 3 rice exporters in the world. Many Southeast Asian countries, we also know, import food and feed with long supply chains, which are very vulnerable to disruptions and have huge carbon footprints. And finally, diet diversity is increasing in Southeast Asia, especially in the urban sector and amongst a growing middle class. And this is driving the demand for animal protein and processed food. There are 3 buts I want to share with you. But we know that a nutrition transition is occurring, in which diets are becoming higher in processed foods, which are high in fats and sugars. And one of the resulting consequences is, of course, the higher incidence of non-communicable diseases. Now, we also know that in Southeast Asia, according to the FAO, 9.2% of the population are undernourished, and about 20% of people are in moderate to severe food insecurity. So the other but is that, so despite successes, Southeast Asia agri-food systems show symptoms of decline, whether it's the degradation of natural resource base, the biodiversity loss, or the rural-urban inequities. Okay, we see all this even before COVID-19 hit us. Now, what COVID-19 has done is to highlight challenges to Southeast Asian food systems to achieve sustainability and resilience. In a very simple manner, I classify this in the supply side and demand side. On the supply side, we have seen major challenges to ensure the continuity in supply of inputs, fertilizers, seed, feed, pesticides, and so on, for agriculture, aquaculture, and also for food processing for the matter. Okay? We've also seen a shortage of labor for farming and food processing due to measures to limit spread of the virus. Then enterprises have been going out of business, price hikes have occurred, agri-food supply chains, as I mentioned earlier, have been disrupted. And all this really illustrates how vulnerable some of our agri-food subsystems are here, I think, in Southeast Asia, especially the urban systems of production, particularly vulnerable indeed. On the demand side, the reduced demand for agri-products, because of the close down of many non-essential services and enterprises, which we've all seen in all of our countries, increased unemployment, especially amongst daily wage workers, of which there are many in this region, and consequently increased hunger and undernutrition, especially amongst the vulnerable sectors of society. Here, again, I mentioned daily wage workers and also children. And of course, the close down of food and beverage outlets, resulting in high potential food waste, and also giveaways to food banks, at least one positive there. And hoarding. We've seen reports of hoarding in several countries in Southeast Asia. So these are kind of the benchmarks that we need to have in our minds to further our discussions. I'll put to you that many of the challenges that we see to help us increase resilience and sustainability are anchored on science, technology, and innovations. And I wanted to share this slide, especially to disaggregate the food system environment, as suggested by the high-level panel of experts, into the four components. And we might agree or disagree on the nature of the components, but certainly making food available through production, imports, and stockpiles is one key aspect of the food system environment. Physical access, economic access, and certainly the food utilization part where the consumer really comes in, nutrition, health, food safety, sanitation, and so on. And also, very simply in this particular slide, shown some of the technologies that could be used to help us increase sustainability and resilience in each of those four environments. In the bottom left-hand box there, I've mentioned digital tools for smart farming, biotechnology, new farming modalities, just as examples of what are possible. And of course, in terms of access, supply chain logistics, of which they're increasingly sophisticated AI-based, machine learning-based technologies to help us safeguard those supply chains, like e-commerce, traceability, and of course, finally, in the food utilization aspect, novel alternative food, which is one of the fastest growing markets in the world here in Asia, and particularly in certain Southeast Asian cities. Then there are aspects of technology to help prevent food fraud and also nutrition enhanced food. Now, to focus all this, technologies come in all shapes and sizes. I particularly want to focus on disruptive technologies. I think a term that's been used and coined to particularly refer to the game changers, okay, in terms of technology. And some of these disruptive technologies definitely can be used to help us in Southeast Asia, increase farm productivity and total production, and improve food and nutrition sustainability. I list here 8 of these disruptive technologies. Digitalization in agriculture, not just in the production, but in the post-harvest, and also the knowledge technologies that come with digitalization. In the old days, we used to talk about, not giving just the fisherman the fishing rod, but also teaching him how to fish. In today's world, it's not just giving somebody the seed, but also the knowledge to most effectively use that seed or fertilizer. Now, the knowledge technologies combined with digital finally allows us to capture all this knowledge in handheld instruments or remotely to cloud and so on, which is a really significant development in this region, even for smallholder farmers. Then biotechnology for crop and animal improvement, including nutrition. And this is beyond just the genetic engineering, which is so controversial. I'll share a couple of more slides on this later on. Controlled environment farming, which is almost totally based on digital technologies and disruptive technologies. And accompanying that are novel farming modalities, which we're starting to see now emerge all over Southeast Asia. Then the fourth set of disruptive technologies, this is ensuring product integrity and fraud prevention. Fortunately, in Southeast Asia, we have not had that many cases of food fraud, unlike some other regions of the world. But product integrity is a matter of great concern to most urban consumers. You want to be sure that what you're paying for is what you're buying, what you eat is what you intend to eat, basically. Then the fifth set of disruptive technologies, these are supply chain logistics, infrastructure, and risk management. I won't spend much time on that. And then just moving on to mention circular systems, using food waste in particular for increased nutrition and also animal feed, generating new ones from there. And this links to number 8, which is aggregate food waste valorization. Okay, food waste valorization in particular has become very common conversations now when we talk about circular economies. Okay? And then, of course, novel food, the alternative proteins, just one example. So these are 8 disruptive technologies that I would like to share with you, which I think is strongly going to influence the way we view our food systems and the way our food systems are transformed, okay, from production all the way to consumption. Okay? Now, let me just amplify these points by sharing a few more slides. I mentioned the digitalization phenomenon, and I think we're all very familiar with Internet of Things systems or farm production, whether it's rural or urban. And then, of course, the e-commerce systems that have become so important, not just essential, but important because of COVID-19. People not being able to move out and so on. And many of those of us who study this situation realize that, the COVID pandemic is just perhaps a harbinger of things to come. Okay, we're going to continue to see many, many other kinds of disruptions hit us in Southeast Asia, and also Asia and the world as a whole. Now, the next opportunity is biotechnology. Again, schematically, we've seen how GMOs have affected the many countries, only a few in Southeast Asia in terms of planting, but certainly in terms of the food that we eat, the imports. Okay, many countries in Southeast Asia today import GMOs for processing. Now, but we've moved beyond that now. There's the so-called plant breeding innovations like gene editing, biotechnologies, which in most cases are not considered as GMOs. And then even moving beyond that, combining different sets of biotechnologies. One that I'm quite familiar with is the genome editing with induced gene silencing, which really enables us to tap into the natural variability that we see in genomes that we deal with commonly. Again, no time to go into any detail on that. Moving on to the next disruptive technology, which I really wanted to illustrate because it is growing so fast in Asia and also in Southeast Asia. Innovations in controlled environment agriculture, which in many cases are linked to urban farming. CEA, controlled environment agriculture, is really a direct response to climate change, but also to be able to produce more in limited space. We've probably all heard about the vertical farm factories, vertical farms of different kinds, aeroponics, hydroponics, indoor fish farming, and these are all reality in Southeast Asia and growing very fast indeed in this region. Again, we cannot talk about modern food systems without considering these innovations on their own. Finally, the other fast-growing sector, the innovations in novel future food. And this slide just summarizes it all. From insect protein, which is seeing different forms of processing now, compared to the old days where in Laos, Cambodia, Thailand, you can just eat, grasshoppers and crickets on the roadside. We now see a more sophisticated processing of insects into insect protein, extracted insect protein. On the top right-hand corner, plant-based protein. I hear that in the Philippines, even Burger King is now going to be selling plant-based protein in the form of the Impossible Burger. And of course, we know cellular meat is the next big frontier that's coming online, cultivating animal cells in big bioreactors and producing meat that resembles basically the real meat from animal. Pros and cons about this technology, but certainly it's going to help us address some of the environmental concerns of growing too many animals and the big demand in animal protein that we're seeing now in Southeast Asia. I just wanted to share this very quickly to kind of basically reinforce what I said about disruptive technologies. Indeed, they are real and really going to impact on all of us in Southeast Asia. Let me finish off by spending a few minutes on food system transformation. Here's where, we need to have good mental, conceptual, and even real, I would say, practical models of transformation. Transforming to increase sustainability and resilience is going to require us, in a very integrated manner, to address, first of all, the external megatrends, what some workers have called the socio-technical landscape that we're all exposed to, and then how those, in fact, affect our food systems, at the core of it. And here, the high-level panel of experts definition is a very convenient one to use. And of course, the potential innovations, technical innovations, social innovations that can help contribute to system changes. All these have to be put together to really help us engender change. I want to mention here that it's a saying that I always like to remind myself when I talk about transformation. And this is the one right in the middle in red by George Santayana, a very famous Spanish philosopher. Those who cannot remember the past are condemned to repeat it. I refer you to the left-hand side of this slide. In the 20th century, we saw one of the most dramatic transformations in history of agriculture and food. And this was partly evidenced by the Green Revolution. Okay? Now, we also know that the Green Revolution resulted in a lot of undesirable or emergent effects. Environmental degradation, food waste, overuse of pesticides, just name a few, right? The middle rectangle in red. There were also benefits, where more food security and improved rural livelihoods in some countries, not in all countries, right? So we saw the evolution of this 20th century transformed agri-food system into further thinking. The W Green Revolution, people like George Conway, Rockefeller Foundation were preaching that. It's not just about growing food, but it's growing food in a environmentally sustainable manner and also economically viable manner. Then moving on to novel food production systems, which originated from the West. In this 21st century, I will put to you that we're transforming to an agri-food system that really is seeing a revolution in terms of new technologies and new thinking. Okay? In the old days, we used to say that agriculture or food comes from agriculture. In today's world, food may not come from agriculture. In fact, food may come from the lab, okay, from bioreactors. So I put it to you that as part of the thinking on the transform model, okay, this new agri-food revolution regime, we could ask ourselves, the benefits that we really want and be sure that our transformation helps us produce those benefits. Resilience, reduce carbon footprint, greenhouse gases, reduce loss and waste, regenerative system, and so on, yeah? And that we totally reduce the undesirables, which is more processing, more energy use, and so on, okay? So there's a lot of substance in this particular slide, which I don't have time to explicate at all, but you can probably look at it later on, okay? Let me now move on to my last slide. Going forward, okay, transformation to sustainable and resilient systems really needs to be inclusive, okay, of these 9 points. Okay, that's my proposal to you. The top 4 are points that relate to sustainability. The increased use of sustainable technology, EES technology, E stands for environment, the other E, economics, and social aspects. So EES technology, we need to increase the use of sustainable EES technology and also the increased number of new technology-enabled farms, okay, with the supportive policies and tech transfer mechanisms. Very important indeed. Throughout Southeast Asia, at the moment, we see low investment relatively in R&D. We need to increase that significantly. Not just R&D, but also entrepreneurship, okay, to stimulate more regenerative agricultural production and also improve rural livelihoods. A very key point in maintaining sustainability of systems. Number 3, more support for locally produced, indigenous, nutritious food. We're really losing out here on great opportunities, by having the uniformity that we see in some of our modern food systems, especially in supermarkets. And then the 4th point, more support for smallholder farmers and additional farming modes, new modes of farming, farming in the ocean, farming in saline salts and so on. The next few suggestions are those that relate to resilience, that we need to basically increase self-production within countries. Not so much self-sufficiency, but self-production nationally and regionally. And this is in all types of food, conventional food, alternative food, future food, and also concurrently reduce food waste. They're two parts of the same equation. We need to help build up food stocks, not necessarily stockpiles, but food stocks at regional, national, and subnational levels within Southeast Asia. But learning from examples of regional stockpiles like EPTA, the Rice Emergency Stockpile, and we can learn a lot from those as we move into the 21st century more fully. The next inclusive point for resilience are shortened and reduced carbon footprints of food supply chains. Yeah, I think there's been so much conversation in the last few months, but not just food resilience and insecurity itself, but climate change. Okay? And the nexus of these two phenomena, really suggests to us that you really need to consider those together in concert. Climate change, resilience of food security, all together, the carbon footprints embedded in that. And obviously, more action to safeguard supply chains and manage risk of disruption. The pandemic really showed this. When supply chains were disrupted, and there were groups of countries that moved action to safeguard the supply chains, the continuity of supply chains. Now, in the past, this wasn't talked about very much, but COVID-19 has really taught us, a very sobering lesson, that in order to move forward in the 21st century in transforming our food systems, we need to take into account the fact that not all food systems originate from the same region. In fact, as I indicated earlier, Southeast Asia imports a lot of food from outside the region, and almost exclusively animal feed comes from outside the region. Okay? And finally, let me just finish off by saying that the preparedness strategies. We also need to learn from other sectors, like public health sector, for example, where for many years they've had public health emergency preparedness strategies, very well documented indeed. My colleagues and I actually worked on this, and we produced a paper that shares on how, in the context of agri-food systems, we also need to tap some of those other sectors in terms of preparedness. So with that, I believe I've stuck to my time. Let me just finish off by saying that sustaining Southeast Asian food supply and demand, and also food systems, the resilience of it, is really best done through regional initiatives. But these regional initiatives must build on the strengths of individual ASEAN member states. And you notice here that I've shifted from Southeast Asia to ASEAN, because ASEAN is the kind of political entity that unites all of us. And we do have some of those mechanisms now to work, okay, as a Southeast Asian region, to really ensure that our food systems stay integrated, the integrity of which is preserved, and that we have food security in the future. So with that, thank you very much for your attention, and I'll be very happy to answer questions later on. Thank you.
Okay, thank you. Thank you very much for inviting me to give these presentations. And Dr. Teng has nicely explained how the food system is circular. That is a all sort of different part of the global food system, productions to the consumptions and ultimately the waste treatments. One of the critical component is the primary productions. But microbiome, one of the things I'm going to talk about how one of the components, Dr. Teng talked about digital farming, sensing, the biotechnology, also are important. One of the things I'm going to talk about today is the microbiome tools. And microbiome tools is applicable across all the key components of the global food systems, again, from productions to the consumptions to human health and ultimately to the waste management. But the focus of my presentations today to take agriculture as a model and how the microbiome tools can be a strong help in achieving the food security plus the climate mitigation, which are the two critical components of next UN food systems. So there is a call for agriculture to change to meet the requirement of 50% of increase in the productions to meet the requirement of food for the growing human populations. We all know that there is a decline in the structural decline in the production. So inputs does not translate into proportional increase in productivity. There's efficacy loss, in particular in agrochemicals and the plant breeding programs. But as I said, there's one of the critical requirements or critical call coming from all sectors that the agriculture should contribute towards the mitigation of the climate change. And there is a consumer demand for the food quality, so the less chemicals to promote the human health, but also the environmental productions. And if you look at all the reports that is coming from last decades about the tools that we need to meet all these requirements of the food security, nutrient securities, climate regulation, environmental securities, and have the agriculture productivity maintain and increase, there's a lot of different analysis done from food FAO to other FAO, IPBES, food, and so on, all organizations. This is just one report come from the USA, National Academy of Science, Engineering, and Medicines, that identify 5 tools that we need to really advances by 2030 to meet some of the SDG goals of 2030. And one of those 5 tools is the microbiome. And it is a tools, not just because it brings a sustainable and potentially brings a sustainable increase in productivity, but it is the industry of itself. If you look at the microbiome industry today, its current market is 1 trillion. It's across all the sectors, $1 trillion. That does not include antibiotics that we use in the pharmaceutical, which are mainly microbial in origin. Agricultural biologicals are up to 6 billion today. Out of that, around 4 billion is the microbial. And of that course, the biopesticides accounts for most of those goals. It is going to increase by triple by within the next 5 years to $12 billion. It is increasing in the market value at the rate of 3.5 times faster than the agrochemicals. And in the future, it is considered that its market value, not very distant future, but I'm talking about a very near future, in decade or 2 decades time, it will have a market value similar to the chemical pesticides today, which is $55 billion. And the driver of that, there is some success story here. It is not that people is just estimating. And the success story has been driven by the policy and the what we call the top-down policy decision. Example is the European Green Deal. By 2030, so within 9 years, they want to reduce the chemical pesticides used by 50% and the chemical fertilizers used by 30%. And they are supposed to mainly replaced by the microbial products. And as a result, there has been significant investment both from the government agency, but also the private industries in this area of the research. And one of the critical things is there is a really enormous potential here for the new discovery and innovations. If you take example of the human medicine, pharmaceutical, there is more than 50% medicines have a natural origins. And if you compare to the agrochemicals, particularly the pesticides, only 11% come from the natural products. So there's a huge range of the natural products is there that yet to be discovered in terms of using as a pesticides and the agriculture inputs. Next slide, please. And that has then driven the huge range of the new industry. What we call the microbiome is the fastest growing industry from all sort of industry, from the farm productivity to environmental sustainability to food securities and the quality of food, food productions, and the waste management, ultimately to human health and planetary health. And this excitement then comes from a real understandings that we have developed recently in the human microbiome. Human microbiome, as you know, is critical for the survival of human and for all aspects of what we eat, how we digest, our nutrients health, our physiological health, our reproductive health, our mental health. Everything is linked to the microbiome we host. And that this is the same is true for any other organisms, including the plant and the crop species. But use of microbiome is not new. Is not new tools in the microbial, at least not a microbiome, microbial species or microbial inoculant is not in new tools. we have been using for decades, in fact, more than a century. BT, the Bacillus thuringiensis for insect control, Metarhiziums, and all sort of Trichoderma for the fungal colonies have been using for a number of years. Rhizobia for the nitrogen suppliers have been using for decades. But the problem lies that these are the inconsistent. You put in the fields, it works in one conditions, it doesn't work in other farm, it doesn't work in other environmental conditions or climatic conditions. So the inconsistent efficacy of the product. There's a lack of productive diversity. It comes mainly from few microbial species. And most of the we have millions of species to be discovered and used and developed in the product. The other challenge is technical, the sustaining the activity of microbes. It's not chemicals. You have to keep the microbes in the formulations, which is remain dormant, but survive. And when you introduce in the field, they should grow, colonize, and do what it's supposed to do. And that's what has resulted into the lack of efficacy in the field conditions. And we have been working with a number of other groups across the globe to overcome those sorts of inconsistency in productivity. The word here I use is the crop holoband, which come from, again, human holoband. So the plants and humans are not in the entity of just human cell or plant cell. It is made more of the microbial cells and less of the human cells or less of the plant cells. This is important to emphasize. So it's harnessing both the plant genome as well as a microbiome that is inherently linked to those plants. Is that what we're proposing to address this issue? So there is a growing awareness that we move away from the microbial tools we have, the microbial lubricant industry we have currently, to focus on the SynCom, which is dependent on the number of microbes, but that is directly or physiologically or molecularly linked to particular crop species. The second approach is that we use tools that increase the activity of beneficial microbe, which is already present in the plant root or inside the plant tissues. And the third one is to use the plant breeding program to attract and activate the activities of the beneficial microbes within the plant systems and within the root system. But there is, to achieve those goals, there is some of the fundamental knowledge gaps that we need to address. There is similarly have a number of applied research requirements that what are the conditions that when you introduce microbes in the field are able to colonize and do what it is supposed to do. And there needs to be not just one or two trials. You need to have different environmental conditions, different climatic conditions, different farming conditions to look at the field trials to make sure the products provide consistent responses across different environments. And there is a risk that we need to consider as that goes across, again, all sectors of microbiome, from foods, productions to consumptions and harvests. That includes the applications risk. Make sure they are not animal and human pathogens. They needs to have the food safeties needs to be looked at. There's a social risk. Dr. Teng talked about the genetically modified organism or the perceptions of the public about genetically modified organisms. We need to address this issue upfront, that the microbiomes is our friend and not our enemy. There are some pathogenic microbes, which are very few. Most of microbiomes are our friends, and use that. And then there is a regulatory requirements which needs to move with as the science is moving. At this moment, it's pretty archaic, honestly, but there is efforts to address that. So what we're thinking is that the solutions, the future solution is to look at a system-based approach. You look at the plant species, plant genome, associate microbes and microbial genomes together and develop solutions which is based on that approach, considering the environmental conditions and the farming conditions. Target the microbes which are inherited from the plant species. As a result, you have more colonizations and better efficacies. Some of the things we haven't talked today about is essential. There is a public-private partnership in those sort of issues for the early adoptions and commercialization of the product, and a coordinated global approach to improve the outcomes. And there's a philosopher say that this sort of tools take a long time to come into the practice. So we have to have a long-term vision. We need, and rather than short-term outcomes. If we have a long-term visions and we be patient, this technology is just about to take off. And I'll finish this presentation with the initiatives that will lead to address some of the issues we talked today, what we call the Global Initiative of Crop, Microbiome, and Sustainable Agriculture, which have around 158 partners across 72 countries. You are welcome to come and join us if you are interested. We are also launching a new journals with these initiatives under partnership with the Wiley, what we call the Journal of Sustainable Agriculture and Environment. And you all are welcome to join us and to support those initiatives, including submitting your papers. So thank you very much for your time. I appreciate for your patience and the time. Thank you very much.
Thank you very much for Ilse for inviting me. Hopefully I can share some experience about the food industry, especially in Indonesia. Okay, today I will share about achieving healthier diets and encouraging nutritious, affordable foods, especially the role of SMEs in food system transformation in developing economies. And now I would like to talk about the Indonesia specifically. If we talk about the Indonesia, we know that we have the fourth largest population in the world with more than 270 million populations. So we have to provide foods for those populations. And the interesting matter is about the food is a share of food expenditure per capita in Indonesia is significantly high because the food expenditure per capita is around almost 50%, and processed foods contribute is almost 17%. And this is challenging in Indonesia as a archipelago countries. We are challenging in the logistic and distributions from upstream to downstream, from the raw material to the distribution of the finished products. And especially for the SMEs, mostly they contribute in the limited area because their sources, their resource, and also their capability only in the limited area. This is quite challenging for the SMEs for the distribution of their food products. Indonesia has high confidence in the food and beverage industry because the government has a vision for the 2045 where the Indonesia will be 100 years old. The population become more than 319 million populations, and the GDP per capita become more than 23,000 US dollar. While currently our GDP per capita is almost 4,000. With this high GDP per capita, of course, the demand of the foods become more varied, more added value, and better quality, and also more functionals, of course. And household consumption is also contribute quite significantly high, or more than 57% to the GDP. And unfortunately, during the pandemic, 19 household consumption growth is a minus 2.23% first quarter 2021. Fortunately, food and beverage industry still grow positively, where the economic growth contraction is -2 last years. Our food and beverage industry still grow 1.5%. And the contribution of the GDP to the non-oil industry is increasing from time to time. Last year become more than 38% contributions. And first quarter 2021, our economic growth minus 0.74, but the food and beverage industry grew plus 2.45. So the food and beverage plays an important role in food availability and contributes to the economy. This is the number of the F&D industry profit in Indonesia. More than 99% is contributed by small micro industries, food industries, in terms of the numbers of establishments. But for the output value is mostly contributed by the medium large food business operators or companies. So that's why this is the challenging also in Indonesia. Like the biggest challenges for the SMEs is to comply food safety standard in Indonesia, because they have a lack of capital to comply, lack of experience and knowledge, lack of access and of informations, awareness, because some SMEs are focused upon the business survival rather than the compliance with the regulations. And also lack of the adequate resources like water, sanitations, and willingness and awareness. So many SMEs are focused on facing the challenges of meeting the food safety rules. But fortunately, however, currently there are some numbers of SMEs that have started to play a role in meeting the needs of healthier and more functional foods. Later, I will show you some samples of the SMEs who has started contributing in the production of the healthier and functional foods. If we compare in Southeast Asia, micro, small, medium enterprise in Southeast Asia, around 97% is a number of micro, small, medium enterprise in Southeast Asia. In Indonesia, it's more than 99%. And fortunately, the number of micro, small, medium enterprise in Indonesia is contributes considerably high, although this manufacturing sector is not exclusively for food sector. Unfortunately, we don't have the data for only the comparison only for the food and beverage industry. So, but this is showing the manufacture in total in Indonesia is not bad compared to other ASEAN countries. And some surveys showing that the changes of consumers' behavior due to the COVID-19. The interesting thing related to this topic today is about the health and well-being. Many consumers focus on health and hygiene, also acceleration of natural fresh foods. And I think this is some changes in the consumer behavior. And some data showing that there are some increasing trend of home cooking in Indonesia, the pandemic COVID-19, and also the health drinks. Health drinks also increasing and increasing preference towards the organic foods. And also the COVID-19 pandemic seemed to change the respondent diets to be healthier. The other survey said that retaining the habit of healthy diets, trends, and also preference towards home cooking. Ladies and gentlemen, now we are showing the digital literacy status in Indonesia. Why we show this? Because digital literacy and social media is influence to many sectors, aspect of life in not only Indonesia, I think, but also in the world. Yeah, most of Indonesia consider social media as their go-to source of information in Indonesia. And social media is considered as one of the most trustworthy sources of information. Unfortunately, frequent exposure to fake news is aggravated by the lack of ability to identify them. For example, content related to health is considered as one of the topics most prone to fake news. This is the challenging in the new era digital currently. If we talk about the consumer perspective, there are why people are reluctant to eat healthier foods. There are top 5. We can conclude that people doesn't taste good, feel that doesn't taste good because for the healthy foods, and also some reasons because of boring. They said some said expensive and also unsatisfying and no access or difficult to produce. And healthier diets, sometimes we can relate to the cultures. For example, in Indonesia, used to sweet taste and also strong sweetness is acceptable in Indonesia. For example, especially in the Central Java, if you request a tea drink, and then they will serve you with a very sweet tea. And also incorporate sweetness in food as well, not only beverage. But if we compare with Singapore, Singapore used to less sweet taste and also strong sweetness is not preferred. So this is the challenging, how to change the behavior of preference, consumer preference related to the cultures in the several countries. And some surveys said Indonesian consumer views that most of Indonesia consumers are trying to eat more healthy. This is a good, quite a good news. And also healthier products reformulation is widely accepted amongst the Indonesian consumers. And the other data showing that some consumers have not reached the pinnacle of the healthy eating. And eating healthily is generally perceived to be costlier as compared to eating unhealthily. And Indonesian consumer views from based on the survey show that consumers are not entirely satisfied with the choice of healthy options available in Indonesia. So this is an opportunity, I think, for the food and beverage industries to provide more option of the healthier choice, healthier products, and also the other data showing that the growing gap between healthy and unhealthy products and categories that make a sustained effort to become healthier can get recognitions. What is the food industry role? We can say that we can provide some educations to the consumers, to the community with education for healthy and balanced diets, for example, and we can also educate them with sugar, salt, and fat reductions, even though our challenges, as I mentioned, related to the culture in the several regions. But currently, some millennial and generations, they already consider to change their habits of diets to more healthier. And also metabolic disease preventions, we can also provide education on malnutrition preventions. And also we provide some healthier options with several products with more healthy, like less sugar, with less salt, everything's less to be more healthier. And if we talk specifically with the SMEs roles, as I mentioned, some SMEs in Indonesia has started to provide some healthier options, like they already start with the product that they are produced healthier. This is many companies in Indonesia, SMEs in Indonesia already start this one. Also, they provide with nutrition information in their products for information to the consumers. And also, this is quite a big role in Indonesia. Many SMEs provide herbal drinks, what we call it the jamu, because Indonesia is an untapped source of the global market of herbal medicines. And also the players of the jamu in Indonesia is mostly come from the SMEs. And also they're contributing a huge contribution in the local economy. So we have to, moving beyond the food safety, we know that avoiding non-food grade additive, product hygiene. So we have to move beyond. We catering the consumers' needs for healthier food products with the nutritional benefits, going natural herbal drinks with health benefits, also accommodating needs for home cooking. And of course, we do this for healthier Indonesia, healthier worlds, and of course, not only medium big company, but also the SMEs can play a role in this purpose. So as a conclusions, we can say that most of the food business operators in Indonesia are SMEs, but the contribution of SMEs in terms of output is not as large as the medium big food business operator. Most of SMEs still face challenging and meet food safety standard, and also some trend in demand for healthier and more functional food is getting higher, especially during the pandemic COVID-19. And this is also triggered by the COVID-19 pandemic, which has changed consumers' behaviors. Some of SMEs has started to play a role in providing food demand that are more healthy and functional. Changes in business models, especially digital marketing, has encouraged SMEs to play a greater role in meeting consumer needs. And also with digital, I think it's more open opportunities to all sectors, including SMEs, to provide more products and marketing in the digital markets. I think this is my sharing today. Let us discuss for more detail. Thank you very much for your kind attention.
Thank you very much to all the excellent and very informative presentations, and also for keeping the time. So now we will be able to accommodate a few questions. I think I will not be able to do justice to the presentations by presenting a synthesis, but rather, let me just say that the presentations actually unpack the key components of the food system under the broad categories of food supply, food environment, and consumer demand, and clearly drove home the message that one, the food system is intimately connected to global and regional challenges, from various forms of malnutrition to challenges on supply, as well as demand side, climate change, and other issues. Two, we also heard about recent advances in science and technology, which have been labeled as disruptive technologies. This would include digitization, biotechnology, novel foods, and emerging tools in agriculture, like microbiome tools, which can offer, and I think one of the highlights of the presentations is that this, the technologies that have been shared can actually offer not short-term, but long-term solutions, and can promote inclusiveness, equity, and increase the resilience of food systems in Southeast Asian region. Lastly, with the last presentation from Mr. Adri, he shared with us information on challenges being faced by small, medium enterprises and what actually drives consumer demand, and how digitization, such as digital marketing, can be harnessed by SMEs to promote a healthy food environment, as well as reinforce positive nutrition behavior. And hopefully all of this will lead down to a recognition that nutrition can be a financially viable option. Now, you probably have seen that there are a number of questions posted in the Q&A box. In the interest of time, we will not be able to ask all those questions, but I have one that is addressed to Professor Teng, okay? And this has something to do with, okay, let me see. Professor Teng, okay. Can you, is there any contradiction between nature-based products and GM foods? On the one hand, people tend to prefer nature-based food. On the other hand, GM foods seem to also be promoted. So they want to hear some thoughts on this. And we would appreciate it if you can keep your response short. Over to you, Professor Teng.
I'll try and keep it briefly. You know, technically, it's difficult to distinguish, I think, between so-called nature-based products and GM foods. But perceptually, in many people's minds, there are differences. Okay? I mean, suffice to say that, you know, all the GM foods that are available, these are genetically modified foods available, have actually gone through processes of evaluation, safety testing, and so on. So in terms of, try to answer this question, in terms of contradiction, technically, I don't see any real contradiction between those two in terms of they're being different, okay? But I think, you know, people do want natural food. I mean, we can't deny that, okay? So it's a case of, you know, what can you tolerate, okay? You know, in terms of your mindset and mind frame, right? I think like a very famous Nobel laureate said, you know, when people are hungry, okay, they don't really care whether it's nature-based or not. Okay, it's the middle class, it's those who can afford it, they start being more discriminating. But technically, in terms of safety, there really is no difference at all. I think that's my short answer. Thank you. Dr. Tuazon.
Thank you, Professor Teng. Actually, the next question is addressed to all the panel, the speakers, but I would like to request Professor Singh to please respond to this. What is your view on the impact of organic agriculture in achieving food security and sustainable food systems? Over to you, Professor Singh.
Thank you. I think I'll be very brief. Look, for me, that everything has to play part. Organic agriculture has to play part. Organic agriculture itself in the current environment, in my humble opinion, will not feed the 9 billion people. But they can be a critical component, and it is a growing industry itself, to be a complementary farming strategy to increase the quality of product, but also in the long-term sustainability of productivity way by improving the soil health and improving the soil carbon and so on. So overall, I would say that the organic agriculture have a critical role to play in the food security, along with all other farming practices we need to feed the 9 billion people. Thank you.
Thank you very much, Professor Singh. And this is the last question for Mr. Adi. Considering the culture in Indonesia, how do companies promote healthier foods despite the several reasons why people do not like said healthier foods? And how successful are these companies in promoting healthier foods? Over to you, Mr. Adi.
Okay, thank you, Dr. Maria. Okay, what we do in Indonesia, many companies, not only medium big companies, but also several SMEs doing, first we do reformulations. Silently, we do reformulations. We educate the consumers with the healthier product. For example, some of companies now already producing less sugar products, and slowly consumers can accept this. My personal experience, for example, in the beginning of the 2000s, I myself produced less sugars products. Unfortunately, failed because we cannot sell it at the times. And now it's we don't say revolution, but evolutions. Evolution, we educate consumers slowly how to eat, how to take the healthier diets for them and concerns of the healthiness. Now many companies doing this, and consumers can accept the product currently. And I noticed that sales of the healthier products are increasing from time to time, and including also the question for the organic foods. This is also evolution in Indonesia. You can see many organic producers and organic products can sell in the supermarket and the mini markets in Indonesia. Maybe if we talk about 10 or 15 years ago, we don't see the organic foods in the markets, but currently increasing from time to time. And so we call it the evolutions to go healthier diets in Indonesia. I believe many countries also have the same situations. Thank you.
Now I think it's time for us to move to the other segment of this very interesting webinar. And that will be the panel. We will hear from the panel members their musings on the presentations that have been presented. We will give each panelist an opportunity to briefly introduce themselves or the organization where they're coming from. And we have shared with them a set of guiding questions. And these guiding questions are focusing on how we can leverage science to make food system transformation an achievable goal, and also highlight what they would consider as science-based game changers. We also requested the panelists to share their thoughts on science, policy, action nexus, and what do we need to put in place to ensure that science contributes to accelerated and impactful actions. The first panelist is the president of LCC region, Mr. Jeffrey Smith. And then he will be followed by Professor Emorn Udomkes Mali. I'm sorry. I hope I said your last name correctly, Emorn. She is the senior advisor to INMU from Thailand and also a board chair member of IFRI. Then Professor Cecilia Akuin, adjunct associate professor from the Institute of Human Nutrition and Food, will also be sharing her thoughts, and I think she will focus on the food environment. Last but not the least, we will have the director of SIARCA, also based in the Philippines, Dr. Glenn Gregorio. So over to you, Jeff.
Okay, thank you very much, Dr. Tuzon. So I will be very brief. I'll leave just some remarks at the end, but I think we've heard a lot of really good science in a wide range of fields. I think it's clear that in this brief session, we cannot touch on all of the issues that need to be considered as part of sustainable food systems. Prof. Ting talked a little bit about some digital aspects and biotechnologies, but issues of food safety, optimal diets, new technologies like nanotechnologies for precision delivery of fertilizers and pesticides, handheld devices. So there are many things that have to be addressed. I think from our side, we heard a good sampling of some excellent science on some of these topics. And the question is how to improve communication between all of these groups. So if you want better, reduce waste from better food packaging, you need packaging engineers. And those packaging engineers don't need to be experts in all the other aspects of sustainable food systems, but we need some mechanism to link them for communication to help set priorities. So I think from ILSI's perspective, we want to help move all these along and help in the interconnectedness and the exchange of interdisciplinary science to advance these issues in a forward direction. And I would say, as you know well, ILSI doesn't work on policy issues, but we do allow ourselves one advocacy position, and that is we do advocate the use of the best available science in coming to policy decisions, and we hope to continue to provide that science.
Okay.
Okay, Emorn, please.
Thank you. Thank you, Pichai. Thank you for the introduction already. I will try to be brief so the two panelists further can provide their thoughts. The question about how to leverage the science, particularly for me on the consumer side, has to do with, it is true, the demand of healthy diet has never been greater, but it comes with a price tag. As Sophie report in Asia Pacific of 2020 say, healthy diet costs 4 times more than the energy sufficient diet. In Southeast Asia, 325 million people cannot afford that. So this is a challenge, considering the burden of malnutrition in all its forms that are quite significant in this region. Now, one of the things that occurred to me when I listened to all the speakers has to do with the power of data. So I would pick the science of data to help leverage this, to lead the way and inform actions from food supply chain to food environment and to consumers. There are, I would say, data system that can be managed by data strategists to identify who, where, how the goal of food system to deliver healthy and sustainable diets can be reached. The game changer for me is the digital world, the data science and informatics. And you have heard from the speakers excellently, providing a range of those disruptive technologies. But what it does is provide data in real time for decision making. When should you plant? What you should plant in that field? When? And particularly when the crops come out, where to pick it in order to make sure that you pick the right one and it can go down even to the branch of the trees. So it reduces food loss, food waste. These are wonderful. And some of these things are game changers. Particularly, it attracts the young generation into agriculture and food system because they are very much digital oriented. For Science Policy Action Nexus, we talk about this for years, for the policy makers to adopt the science. The main thing about this is that the science generates evidence that guides solution, while policy should act on such evidence to solve the problems. But how do you convince them? The language, I mean, how to communicate between these two groups are probably key. Many of the policymakers say talking to scientists, they have a headache. It's so much technical. So how to build a case? And that requires high quality scientific evidence that could be translated with clarity that leads to policy decision. So you want to give them a practical solution that is also context specific. So for me, this is very much over the years, we say it's policy should be driven by science, by evidence. Science has to start moving in that direction to meet their needs, to convince them. And it's not a one size fits all. We have a lot of data on what. We don't have much, and we need more on the how to. That's all I have for this for now. Thank you very much. Over to you.
Thank you for those thoughtful interventions. Professor Akuin, the floor is yours.
Thank you very much, Pichai, and good afternoon, good morning, good evening to everyone who is listening. I have been asked to focus on the food environment, and I submit that this is probably the most rate limiting of the continuum that Professor Teng had earlier shared between production and consumption. Because as Professor Emborn has said, you know, the consumption side, the demand side will always be there. And with all of the disruptive technologies that Professor Teng and that Professor Singh have shared with us, we know that there is great potential also on the production side. But linking these two, the production and the consumption, is going to be the most challenging, especially in our region. So one way of looking at the food environment would be through what FAO has characterized as our food value chains, which are traditional, transitional, and modern in character. And for us here in Southeast Asia, we have a mix of all of these different food value chains. We have the very traditional, where the farmers themselves are directly consuming, or sorry, directly selling what they produce. And therefore the value chains are very short, but they are also very unstructured, and they are largely unregulated. Then on the other side, as Mr. Ali has shared with us, we have the more modern and more developed food value chains, which are dominated by medium and large enterprises, where there is a lot more regulation, but also there is a lot more quality in the kinds of products that are being sold. Then in the middle, you have those in transition. And here in our region, about half of the enterprises in the food environment are in transition. And then you will have maybe 1/4 who are in the modern, and maybe the 1/4 are still in the traditional. So we have all of the different kinds, and that's what makes it most challenging. But the food environment is also the opportunity that we can take to enhance the nutrition value of foods on top of what's available from the food production or from the agricultural sector. And this is in terms of improving food quality and safety. And I think we really have to address safety, because most of our entrepreneurs in our region are still in the micro, small, and medium that do not really adhere to regulations or are not reached by regulations very much. So we really have to include safety. And the third would be market access, because that is what determines the food and nutrition security of our people. So this goes all the way, you know, from the food handling by our farmers to all the way to the way food is being stored in retail stores and what happens to them in transit. So there is great potential to retain the best nutrients for consumption by consumers, but there is also great opportunity to lose them through poor handling or poor storage. So that is the challenge for the food environment. The other potential that I see for the food environment is that it provides the safety nets for food and nutrition security. And we have seen this very much during the COVID pandemic, where governments were literally forced to provide food to their people because providing cash as a form of assistance was not going to be helpful because there were very few stores that were open or food establishments that were open. So giving cash will not solve the hunger problem of people. So it had to be directly through food. And these are the kinds of safety nets that will be needed, and that is why we need to have good governance of our food and nutrition systems, because that is what will provide the support during times of crisis. It will also help if we have shorter food chains during these times of crisis, as well as opportunities for home production or home-based fortification that will improve the nutrient values of foods that are available to consumers. Lastly, I see the food environment as the most exciting field in terms of the microbiome that Professor Singh has introduced to us. He talked mostly about the plant soil microbiome that is being harnessed already in agriculture. And coming from the health sector, I am very aware of the interventions going on at the gut microbiome level. But even in the food environment, there are tremendous opportunities. We already see microbiome studies, for example, in refining wines or in producing dairy products that are more nutrient dense as well as more stable across different environments. So I wish we had more time, but really this is a most exciting forum and I look forward to the questions later. Thank you.
Thank you very much, Cez. Now we go to the last panelist, Dr. Glenn Gregorio. Over to you, please.
Thank you. Thank you. Thank you, Dr. Tozon, and good morning, pleasant day, and good afternoon and good evening to everyone. I know this is already a long day for some of us, but thank you for inviting us. I'm Glenn Gregorio from SEARCA, which is a long name, Southeast Asian Regional Center for Graduate Study and Research in Agriculture. Actually, we just finished our first year for our 5-year plan, which is actually have a theme of accelerating transformation through agricultural innovation, which is really what we are talking right now. And I'm also thanking you for being involved with this UN Food System Summit, which I was also one of the champions of the UN Food System Summit among more than 100 champions around the world. Now, I want to thank those, we have a very nice presentations from the 3 speakers where they talk about sustainable food system up to the regenerative agriculture, conservation agriculture, using the microbes to help really not only the plant, but the whole system. Now we have also the processing. So we have the whole system, the whole chain of the food system had been tackled, most of the whole value chain. So what I want to say about the guide question for us, this is what do you think we can leverage on science to help transform the food system? Or I will do the specific components of the food system to deliver on sustainable healthy diets. Maybe among others, I just want to focus on the food system, on seed system. I really think, because I'm a plant breeder, I'm a geneticist, so I just want to focus on, among others, is the seed system. Very important. This is a very vital in ensuring our food system. This seed development or varietal development that requires a lot of science, genetics, a lot of physiology, a lot of seed technology, and package it into a good management practice. So I believe that the food system, the seed system is very important. Having good technology or securing food and nutrition security starts with a good seed. If your seeds is bad, if you have a not good quality seed, not nutritious seed, or a good seed, then everything will be down. So seed will start the technology, and it will give you a healthy products and healthy products for the food system. And for what are the game changers? I could see is really, I will focus on consumers' behavior. I think it's the consumers' behavior in the future. Our consumption behavior will dictate the production strategy of today. Aside from the consumer behavior, another game changer I could foresee is the farm clustering via digital agriculture, which is really being discussed by Paul Teng on this aspect, and especially the financial technology, which is very important. The technology that delivers the financial services, from online banking to farm loans to any transaction. This will really empower the farmers, empower the consumers, empower the food system actors to act on this one. So these are the game changers that I want to share. And for the last question about what would it take to ensure that science policy action nexus becomes the rule rather than an exception, I would say that we need to strengthen the policy enabling framework on science policy action nexus. While we see the government as an enabler, we need to understand when and how the private sectors will enter into the picture. It should not be the government alone, they are just the enabler, but it should be when the private sector will come in, that will make it really sustainable. And we have to understand the public sector must also have the mindset that the government is just an enabler and facilitator, and to understand that the private sector is very vital in our food system to make it sustainable. Because sometimes our public sectors are looking at the business side is the negative side of it, or the devil part of it. But we should look at it as a sustainable. They are the one who drives that delivers the food from the farm to the plate. Thank you very much.
Thank you very much to all our gender balance panel. Okay. I think the organizers tried to also ensure that there is gender balance in the composition of the panelists. The presentations from our experts and panelists, I believe, tried to really bring together the knowledge on the different parts of the food system, emphasizing that the food system is an interconnected system of everything and everybody that influences and is influenced by the activities involved in bringing food from farm to fork. And I'm so glad that Dr. Glenn emphasized the seed system, because I'm reminded of the time when I worked in Myanmar, and one of the high officials in Myanmar mentioned it should be seed to mouth. Okay, so I think that also is very much aligned to what Dr. Glenn mentioned. It is our hope that you will leave this webinar with a takeaway message that the connections between the various elements of the food system implies that a single action in one part of the food system can have repercussions across the different parts of the food system. And there are many parts where actions can be taken. Science is integral, science is important, but some of the actions have to go beyond science. And we have heard Professor Emorn talk about the important role of communication. We have heard Dr. Glenn Gregorio talk about the importance of financing and also some of the things that Professor Ces Acuen mentioned. So we hope that this webinar has really provided a good technical compass in terms of what we can promote as game changers in the Food Systems Summit to really help us achieve our overall goal of food system transformation, not only to meet the SDGs, but really to meet our goal of sustainable, healthy diets. With this, I invite Mr. Jeffrey Smith to give the closing remarks and maybe also some announcements about comings. Over to you, Jeff.
Okay, thank you so much, Dr. Jozon. Really a fantastic session. I thank all the speakers for the really scintillating and important science that they've presented. As I said before, we're only able to cover a couple of important aspects, and obviously we have to leave out for this purposes of this session many other critical aspects which we don't want to at all underplay. Food safety has been mentioned a few times. Issues of reducing food waste and improved recycling, aiming towards a agri-food circular economy. Food science and engineering, I think, will play an important role. This sensors technology has been mentioned. I think that's going to be also a game changer, which is not always realized at this stage. Important aspects of certain population groups, so maternal and infant nutrition, really critical, and healthy aging at the other end of the spectrum, also very important. I would just mention, in terms of announcement, ILSI is going to have a science dialogue, which is part of the FSS21 pre-events. Understand the dates on July 26th. So the details, I think, are not completely available, but that will be on the ILSI website on healthy aging. And as some of us age a bit more, we are interested more and more in healthy aging. So we're very pleased to have been an important part of this important session for the Science Day events. I think they all look really, really excellent. I would point out too, with links to our region, tomorrow, which is July 6th, there's going to be a session on strengthening international food research cooperation on food systems, which is supported in part by the Australian Centre for International Agricultural Research, ACR. And on Wednesday, there's a session on regenerative agriculture organized by the Thailand National Science and Technology Development Agency. So you've heard a little bit about microbiome, plant microbiome, and soil microbiome, which is linked to this regenerative agriculture. We had a scientific session in April with which included Professor Ratan Lal, who is the winner of the 220 World Food Prize on regenerative agriculture. So those are two of the very important sessions that are going to be going on later today and tomorrow and the next day, followed by the official Science Day events on Thursday and Friday. So again, thank you for attending today. Thanks to our collaborating partners, SIARCA, the Academy of Food Science and Nutrition of the Indonesian Academy of Science, and ILSI Global. Please note the link in the chat box to some of the reference materials for today's speakers, and please contact us with any questions, comments, or proposals for collaboration. Thank you very much, and goodbye.
Thank you very much to everybody. But before we finally end, I think we want to also recognize behind this very successful webinar, led by Mrs. Boon Yi Yong, Pauline Chan, Janice Lee, Wee Kay Lee, and Professor Aman Wira. So thank you also very much for the excellent support that we have received in organizing this webinar. And to everybody, I join Jeff in saying thank you for making this a part of your day. Goodbye. As we say in Italy, ciao, ciao.